Hello, and welcome back to Math Explained. So today we're going to be talking about variables, which of course are just the letters that we put in our little equations. So most of the time people are doing all fine and good in math and they're going along and everything's good, and all of a sudden they come to something like this. So we were fine with 2 times a number minus 1. So if you had 2 times 3 minus 1, that we're okay with, right? Because you have 6 minus 1. That just gives us 5, and we were happy with that. Now we have to change it up, and all of a sudden there's a letter there. This is not cool, man, not cool. Except that really it is cool. So we have this expression like this. It's 2x minus 1. And the problem with the expressions is that there's an infinite number of numbers, an infinite number of equations, and why would we memorize all that? Like it would be terrible trying to figure out which one was which. So if we have something like this, and we know we're going to be doing, so this, and if we put a y in front of this, so y equals 2x minus 1, this is really a line, right? It has a slope of 2, a y-intercept of negative 1. So if I draw this, it looks a little like this, like it's kind of steep. Okay, so that's that. Well, if I'm looking for what this equals, then for every single different x, I get a value for that y, right? So I have an x value, I have a y value. So anytime I put any x in there, the answer changes. Well, again, I could put anything in here, so I don't want to have to memorize all that. So what I do instead is I use this x. This x, this variable, which it varies, it changes, this is really just a placeholder. So this x in this equation just says, hey, look, we need to put a number in here, and if we put a number in here, our y is going to change. But what we're doing the math on is this 2x minus 1, but we don't know what we're going to multiply the 2 by. It could be anything, so we just write it as an x. What we're really saying here is our x is a placeholder, or I like to think of it as a bucket, right? Because we could put stuff in our bucket. So if you have a regular bucket, you could put like water in there, you could put like cat litter, you could put gold coins, you could put dirt, you could put anything, right? Because it's a bucket. Same thing with this. So this x is just saying, hey, we want to put something there, but we don't know what it is yet, so we're just going to leave it as an x just to let you know, hey, this is our bucket, this is what you're putting stuff in. So if I have, let me come over here, so I have y equals 2x minus 1. I'm going to draw it as a bucket because I like thinking of it as a container. It's my bucket called x minus 1. So I could come along and I could put like literally anything in my bucket. So I could put a 3 in my bucket. So that would be 2 times 3 minus 1. So we already did that one, that's 5. I could put a 10 in my bucket. So that would be 2 times 10 minus 1, so that would be 19, right? Because 20 minus 1. So all we're doing is we're putting stuff in our bucket, and whatever we have in the bucket, we're multiplying it times 2. And then we're going to subtract 1. So this doesn't even have to stay simple. It could be all wild and crazy. Let's say you have something like this. Let's say you have y equals x squared plus 3x minus 4. So in this case, we're doing other things to our buckets. We still have buckets, right? Our x's are our buckets. Only this bucket is squared, which really that means bucket times itself, right? Bucket times bucket. Plus 3 times bucket minus 4. So anything we put in, so this is plus 3 times bucket minus 4. So anything we want to put in there, we just stick it in a bucket. So let's say we wanted to stick a 5 in a bucket. So I would come along and go, okay, well, I'm going to put a 5 here. I'm going to put a 5 here. So this is 5 times 5, so this is 5 squared, plus 3 times 5, minus 4. So this is 25 plus 15 minus 4. So this one gives me 40 minus 4. So this is 36. So all a variable is, like literally all a variable is it's a placeholder. It just tells you, hey, don't worry. It's okay that it's a letter. I'm only just putting a letter here because we want to put a number in it, and I'm holding your spot. So all you do is wherever that X is, you're just going to put stuff in there. And here, this is mind-blowing, okay? Let's say you have f of x. F of x is just another way of writing y, so it's the function of x. Let's say your f of x is 3x plus 10. Well, that's 3 times the bucket, because your x is a bucket, plus 10. Well, so we've been putting numbers in there. You don't even have to stick to numbers. You can have something like this. This is wild and crazy. What if they come along and they go, okay, well, what's f of x plus 2? In this case, what you're putting in your bucket is x plus 2. So wherever your bucket is, instead of putting just a number, you put that. Well, it's no problem, right? It's a bucket. It can hold anything. So we just go, okay, well, I'm going to do 3 times whatever's in my bucket plus 10. And in this case, what's in my bucket is x plus 2. So then I can distribute my 3. So I have 3x plus 6 plus 10. So that just equals 3x plus 16. Now sometimes you'll have people that say, well, you got to keep your equation, you got to be consistent throughout. So I would do like this and make sure you still carry this all down. Da-da-da. But this is our final answer. So we treat these letters just like we would any number, and we just recognize that these letters are really just holders. They're just buckets for whatever you're going to put in there. Yay!